Hello, welcome back to another video in our computer science educational learning series. Today we're going to be talking about Intro to Data Management Foundation. We're going to get deep into the world of databases, data management, data administration, database design, all that fun stuff. So let's jump right into this first slide here. We're going to be discussing database components. Now, this is a good overview of knowledge to have, but it is by no means required knowledge. If you were to create your own database manager, then you'd need to know how these 5 components interact. As far as querying a database or interacting with a database in those ways, a lot of this stuff just kind of goes on behind the scenes and we take it for granted. So firstly, the catalog or the data dictionary. It is a directory of all the tables, columns, indices, and objects, and it is used by other components. The log is a list of all the operations that have ever been performed on the database. It is written by the transaction manager prior to making an actual transaction. We'll see why in a little bit here. And the log is used to restore data in the event of errors. The transaction manager acts kind of as a safety net. So before a transaction is made, it's going to write that in the log. And then if the transaction fails, then it can restore the data by looking at the log. So an example of this would be if I have a bank account and my friend John has a bank account, and I send John $2,000. What if John deletes his account prior to him receiving the $2,000? Does my $2,000 disappear? No, the transaction manager realizes, oh, we failed to transfer this funds to John's account, so we're going to reimburse. Next, we have the query processor. This is going to be where your error handling is done. It's also going to be where the optimization is done, and it returns instructions to the storage manager. Optimization in terms of what is the most optimal way to access the data that this query is describing. And lastly, we have storage manager here, which retrieves instructions from the query processor, accesses and modifies the data. So the storage manager is where it's actually getting these low-level instructions from the query processor and then breaking that down into machine code to tell the database, oh, I'm going to access this bank account, show me what the balance is. Or, oh, I'm going to modify this bank account, add $100. So let's go on to the next slide here. Next, we have database roles. So we have a database designer, a database admin, a database programmer, and a database user. The designer is going to be in that analytical stage of how are these two components going to interact with each other? How is a customer at a restaurant going to interact with the products sold at the restaurant? And how is that going to interact with the order that they make or the products that gets shipped in by the restaurant or the employees? So the designer kind of says, what are the important components in this business that needs a table of its own, and how can that table interact with other tables that have been created? Now, a database admin, they're going to control the authority levels of people in-house that have access to the database. Somebody on the lower level, maybe just an accountant in this firm, maybe they only have access to view data, maybe only change certain columns. Right, you'll have the permissions to change a customer's balance or a customer's marital status, but you won't have the same permissions for your other employees. So this is where the levels of authority come in. Next, we have the database programmer, and the programmer is going to write scripts and implement the database design from the designer to make it functional within a database. And lastly, we have a database user. The user will be the one writing the queries in order to view the data, in order to insert, update, and delete the data. So those are the database roles, and you'll see that coming back through every slide here. So next we have some expectations for every database. One, we want quick performance. If I have 1 million account holders in my global banking system, I want to be able to access their values quickly. And that is somewhat a burden of the query processor who has to optimize queries. Next, we have authorization levels, and that's in-house opposed to security in out-of-house. So the authorization levels, that is going to be primarily part of the database admin roles, but it's something to think of. Who's going to have ultimate control and authority over all the tables, and who's only going to have selective control? Next, we have security. These are preventative measures to ensure outside users do not have read and write access to sensitive information. So if I'm a user on a banking app, I have read and write permission for my own account, but not for anybody else's account. If that were the case, that would be a security risk. Next, we have rules. Data is consistent with business rules. Let's say I have a night security guard and we only have one guard per shift. There's only one person on guard. In order to remain consistent with business rules, 2 data points of the shift should not overlap. So these rules are generally created on a case-to-case basis. And one rule for one business might not necessarily be the same for another rule for another business. And lastly, we're going to talk about recovery. This is the most important thing in a database. I swear to you, there have been so many horror stories of people losing tons and tons of sensitive, valuable data. Do you have a backup? No, I didn't think we need it. Well, you always don't think you need a backup until it's too late. So that's why recovery is so dang important. Let's go to the next slide. Next, we're going to talk about queries and CRUD operations. So queries are commands that access or modify databases. They are processed by the query processor. Query languages are programming languages for writing queries, like SQL, for instance. SQL is a very famous query language. Programming languages like Python, Java, and C# can interact with databases using APIs. This way, I can write a query in my Java code and have it execute to a database through an API. Now, CRUD operations are essential for full database functionality. CRUD stands for Create, Read, Update, and Delete. A program supporting these ensures basic data management. So create, a new user is added to the bank. Read, I can see the bank account user's balance. Update, I can update their balance by adding $100. Delete, they left the company. Pretty simple stuff. Let's go to the next slide here. Database design phase. So this is going to be the last portion of this introductory phase. The design phase starts with analysis, analyzing the situation and seeing what are the main components and how are they going to interact with each other. So I can say a movie is directed by a director, and a theater shows a movie. This gets into a little bit more complicated once we get into a full video just about database design, but we go into the logical design aspect of it. That's fine. We can understand a movie's directed by a director and a theater shows a movie, but how can that be implemented in a way that a database can be functional? A director can direct multiple movies, and movies can have multiple directors. This causes a many-to-many relationship, and it requires a junction table. With a many-to relationship, it is pretty much impossible without a junction table. So the movie directors table can include a director ID and a movie ID. This way, Indiana Jones and the Temple of Doom 1984 can have 2 directors, namely Steven Spielberg and James Mangold. So how this would work is the movie Indiana Jones and the Temple of Doom 1984 would have an ID of 1, and then maybe Steven Spielberg and James Mangold would have an ID of 1 and 2 respectively. So that's all good and fine. In the directors table, maybe we'll have their first name, their last name, their date of birth, and then the movies table will have title, directors, length, rating, release year, all that sort of fun stuff. And then in this junction table called movie directors, I can say Steven Spielberg with a director ID of 1 directed Indiana Jones and the Temple of Doom 1984 with a movie ID of 1. And then the second item in the movie directors table would be James Mangold with a director ID of 2 and Indiana Jones and the Temple of Doom 1984 with a movie ID of 1. So there I have 2 data points that are 2 separate directors, but they both point to the same movie. So this can alleviate the many-to-many relationship conundrum with a junction table. That concludes our introduction to data management foundations, and I hope you guys enjoyed. I'll be making a lot more videos specifically about data management in the coming weeks. If you have any recommendations of what you'd like to see next, please leave a comment down below, and I hope you have a good day. Thanks for watching.